Hey, this is Steven from LegitTechTutorials, and welcome back to our product design series. We are back working on our dimensional control module and our automatic spooler module. So we are finishing up. We're getting really close to being finished here, and then we're going to be working on... Oh, let me turn off my Skype 1 second. Turn off that. We're getting really close to being able to start printing these guys and then do the software and then get the parts in, etc., etc. So we're finishing up, and also I noticed that there is one other module that I don't know how many people are going to be ordering, so we might have some time extra to design it and focus more on these guys. Is the direct drive. So what the direct drive is it's a module that looks basically like the dimensional control here, like this, except for here it's also kind of like this guy, this cone, where instead of this drum, you have like the cone where it has the what is it called, the coating around it, the rubberized coating. So instead of this, it would have a rubberized coating around it, and what it would do is it would actually pull the filament through. So instead of winding it, it will just pull it through, and then, for example, if this was your table or whatever, it would just spit out on the table. And then you have an open end at one end, and the open end would go right into your 3D printer. So instead of spooling it and collecting it, if you're a person that only uses one size and one color of one material, one type of material, so if you do PLA, and we use not necessarily one color, you can do whatever color, but PLA and one size die, then you could use this guy and just keep making that PLA. And if you only use one printer, so what you do is go turn on the extruder, let it heat up, turn on your printer, extrude, have it pull the filament down, and then put that open end in your printer, and then immediately turn on your printer and start printing up the filament that's getting pushed out onto the table. So you would have them both running at the same time. The main issue with that is that the spooler is way faster than the printer, but we'll be able to slow that down as far as a percentage in software eventually. All right, so we'll have to see how many people. I just sent out the international survey today, so we'll see what people say, and we'll figure that out. So we'll see if people want the direct drive or the automatic spooler. I'm gonna say most people are gonna be wanting the automatic spooler. Alright, so what we're doing right now is we're going to check through most of the stuff and see and make sure that everything's good. So mainly in this video we're going to be checking 3D printer orientation, figuring that out, and you know, how we're going to print it, and if everything looks okay. So first off, this guy is going to be printed like this, which this looks fine to be printed that way. It'll work. So all these pieces, and let's just take a quick look. Let's select all the bodies, right click, physical material. Let's put in some plastic ABS. Alright. And let's figure out general properties. Properties 0.02, .01, so that's 0.15, 0.26. What are these two different lengths? Oh, 0.16, 0.26. This is so 0.4 ounce mass. So I'm wondering if that's talking about 0.5 ounce weight or mass. 0.5 is not much of anything. 0.5 ounces. So I'm wondering, it's talking about weight. Weight times 32. 0.5 times 32 is 16. So that means it's a pound. I don't know. Okay, it looks good. It looks good. Pulley mount. Everything on this guy looks good. Let's put a ABS material on it. Take a look at the mass. I hate when it doesn't. Okay, physical material again, annoying. Oh man, I hate when it does that. There we go. 0.15 ounce mass. This is ounce mass. Yeah, so I'm wondering if that is 32 multiplied by 32. So that means that this guy. Alright, let's see. 28 divided by 16. So it's saying that's 1.75. So 28.43 multiplied by 32 divided by 16. £56. No, this has got to be the actual. This has got to be a force. This makes sense as a force. 1 point something pounds. That makes sense because this is. Six inches long. Yeah, I could see that. This guy, so this guy's gonna have a lot of issues. Let's go through the rest of these guys. Pulley. This guy, why is he not? He's looking really weird on everything else. This guy looks good, ready to go. Ready to put bearing in there. This guy's supposed to have. Oh yeah, that reminds me, I need to do drive shafts for this guy. That I need to have the motor for that, so it's a good idea to have the motor for that. Pulley mount. That guy looks good. This guy could be printed. This is going to be difficult. See how well that bridges correctly. And this is definitely going to have an issue, so we'll figure this out. I mean, I'll have to see, fellas, with this guy here. Might have to do supports on this. Not too worried about that, but okay. Alright, yeah, support's not gonna be a big deal for that. Alright, so that one I'm okay with. Except for this. Maybe instead, I have an idea what I'll do. I'll do a little cheat. This right here should be fine, but this, on the other hand, is not. And this is 45 degrees. So what I could do, let's go from there to there. Okay. So that could go up to about 45. This is too much. Anything below 45 here, and you start to get a little wonky. Okay. So then what I'll do, like that. And then this will just be missing a bolt. Alright, I like that one. Otherwise, I just put a support on there. Not a big deal, that face is not that important. But the idea is just to save as much filament as possible, and supports can sometimes F things up, so you kind of don't really want to rely on it. This one, on the other hand, this is the one that I'm going to have to definitely monitor and figure something out. So here is going to be an issue. So I was thinking of printing it this way, but the square is going to have an issue at the top. This is going to have an issue, so I want to print it flat. Flat gets rid of most of the issues. This will work because I have the opening at the top. Okay. Because I'm not going to be able to do supports inside this thing. It's too far of an area to bridge. So what I'm going to do is I'm going to have it bridge. I'm going to sand the crap out of it. That's what I'm going to do. So what I mean by that is let's get a realistic idea of what this actually has to be here. So what does this actually have to be? So this entire thing is 1.125, which is what this is. So this is half the radius, and the other one's half the radius. Which that means it won't even move. Uh-oh. That's not gonna work. There'll be definitely a lot of this figuring stuff out when I start printing it, but diameter is 2 inches. Radius is 1 inch. So this is just an extra. So it'll only move 1.25 because this is also another 1 inch this way. So it has 0.5 of an inch movement You only do 0.5 this way and 0.5 that way. .5 this way, 0.5 that way. So 0.25, 0.25. So what I'll do is I'll draw a line. This is going to be 0.25 this way, 0.25 this way, and then a line is 0.25 this way. Or another way to do it is do a square. .25, 0.50, whatever. Yeah, so what I'm gonna do is I'm just gonna have that be a slotted. So keep this solid. Let's cut that out. Alright, so that's the only thing that we need to move. So in that case, it only needs to bridge ½ inch. Which, if you're thinking, the filament's not going to be any bigger than that. So I mean, ½ inch is huge. The filament's only going to vary just a little bit. So like maybe we'll only have. Oh, and then you have to think about how big this other guy is. This guy. How big that is. That's huge. Oh, 0.35. So yeah, it's only going to move in there. It's only going to move just a little bit. So 0.35 minus, so that's 0.15. .15 is about 3.6 millimeters. So that's about the most I'm going to worry about it. Alright, so that's what we got. Looks good. Looks good. It should be able to bridge that. Bridge half an inch. So basically what this means, yeah, so let's see, yeah. I'll be good with 1/4 inch either way. So I only have 0.15 up or down, so that means only like 7.5. 0.75. So let's say 0.8. That's probably 2 millimeters. 2 millimeters up or down. That's fine with me. Alright, so let's see, we're at 20 minutes. Alright. Okay. That looks good. That looks good. Now this guy, maybe change this guy a little bit, and then I think we're good to go. A few things that I want to do on this. I want to make a few circles. Something like that, 0.05. And over about 0.25, that's way too much. 0.20, 0.15, right there, that's fine. 0.15, 0.15, and then do a circle. 0.3, 1.4 millimeters. Let's do 0.5 millimeters. Oops, 5 millimeters, 5 millimeters. Ooh. Okay, let's make this 7.5 millimeters. Oh. Can I do perpendicular? I don't think that's gonna work. It's a minuscule little line. Let's see, perpendicular. This one perpendicular to that one. Maybe that might work now. 7.5 millimeters. What the hell? So let's make this 0.1, 0.125. This one over here, 0.125, 0.125. I'll make this circle. For 5 millimeters. Circle 5 millimeters. And then if I want, let's do 0.25. Alright, so that's where we're going to have the two pieces do that. What was this guy again? 0.197. 0.197. Oh, I could just do a circular pattern. Derp. It's not going to be exactly perfect when I do circular pattern because it's off, but you get the idea. Circular pattern, center point. I want 4 on each corner. And then alright guys, I mean, I don't know, I think we could start looking at doing some printing of these parts and take a look at how they look. Alright, well, that's pretty much it for this video. We're actually stopping on time. Yeah, I don't really, off the top of my head, looking at this, we're just going to start looking at some general printing stuff and see what breaks and what doesn't. Try to find some bearings, some 3D printed bearings, and see how those work, or metal bearings or whatever, and then start to modify the designs to get those to work. But as far as this video, I mean, we're pretty much ready to go as far as starting to print. Check these out. So I'll start printing some of these. Some of these I could do on my printer. These big ones I cannot. These big ones are too big for my printer. Those will have to be done at TechShop on the MakerBot. These smaller ones that I could print vertically, I'll be able to do at home. This one, the spooler here. This one, and this one I can do at home. So only two I need to do at TechShop. It's a good deal. Alright, well, I guess that's pretty much it for this video. We're going to be on to printing and figuring out what we need to change and what we could modify. Alright, I'll thank you guys for watching. If you like this video, please subscribe for more videos like it in this series and other series as well. I'll see you guys in the next video. Thanks for watching. Take it easy.